In this module, we're going to look at how to install the SQL Server 2016. We're going to talk about the considerations you need to take into account before you start your installation, prerequisites, components that need to be in place, software that needs to be available. We're then going to look at the installation process. We're also going to talk about TempDB and what TempDB is and how we can improve the TempDB operation in a SQL Server instance. We'll look at the installation process and how the installation takes place. We'll talk about how to do the installation using a wizard. And then we're going to finish up by looking how to automate installations of SQL servers. So when we look at the hardware and software requirements, it's important to understand that it really depends on what features of SQL Server you're going to install and on what platform you're going to install it. So, if you're talking about a Windows CE platform, for example, Compact Edition, then you're talking about a different level of operating requirements. But as a general rule, we talk about processors. The minimum is 1.4 gigahertz processor speed, but the recommended is 2 gigahertz processor speed. The memory also depends on the platform. For SQL Express, for example, the minimum is 512 megs of memory with a recommendation of a gig. For standard editions, standard enterprise BI editions, the minimum is 1 gig, the recommended is 4 gig minimum. But remember, SQL is a very memory intensive operation, so the more memory you can allocate to it, the more efficient it will be. The disk, it all depends on what's going to be done with the SQL Server, what its functionality is going to be, but they mentioned that a minimum of 6 gig is required to install the SQL Server service. But again, it depends on what features you're going to add as to how much more disk space is going to be required. In addition, don't forget, if we're talking about the relational database or even analysis services, you're going to have databases that are going to store information. You got to make sure you have plenty of disk space for your databases. Now, when we talk about the requirements for the software, again, the operating system will depend on the platform that we're going to install it on as to what operating system is going to be required. We could install this on desktops, Windows 8, Windows 7, Windows 10. Prerequisites, the only prerequisite that is absolutely required is the .NET 4.5 SP1 framework. So you got to make sure you have that installed. And in older versions, SQL would download and install that for you, but it doesn't do that any longer. They also mention in the text that you might want to pre-do this because it may require a restart. And as far as general software requirements, the Windows Installer 4.5 is required. And again, same thing there. You might want to download it and install that before you're ready to install SQL in case it requires a restart. So when we look at what CPU and what memory requirements we're going to need for a SQL Server, the CPU part is a little tricky to try to identify, mainly because most products don't really utilize CPU resources as much as others. SQL Server, on the other hand, could, depending on the types of transactions that we have occurring, the types of databases, the frequency of changes, the frequency of modifications. Things like that can all affect a lot of the overall performance. The thing to understand here is it's going to be workload dependent on the CPU requirements that you need in order for you to be able to handle the load that the SQL Server is going to have. One important note is that starting with SQL Server 2017, we no longer can install SQL Server on a 32-bit platform. So it has to be 64-bit in terms of the CPU in order to support the SQL Server environment. What you need to do to identify is you have to first get your workloads, identify your workloads, and then identify them on different types of processor environments. Now, one advantage to virtualization processes like cloud services is the ability to spin up different virtual machines with different processor architectures and test them against those different loads. The memory is probably one of the most important factors and resources when it comes to SQL Server. For those of you who have worked with Windows products in the past, you can never go wrong by throwing more memory at something. It's important to understand that, again, starting with SQL Server 2017, there are no more 32-bit additions, so this idea of AWE or Advanced Windows Extensions is no longer possible. So everything is going to utilize the memory. Now, if, depending on the edition that you want to use, If you're going to look at SQL Server Express, it's important to note that SQL Express has a max usage of 1 gig of memory, which can really limit the size of the database and the functionality of the database. Keep that in mind when you're looking at your workloads and identifying the usage of the memory that's going to be required. So when we talk about the I/O environment, we're specifically looking at storage and the performance of the storage environment. As always, you need to plan how you're going to store your SQL data. We'll look at this in much more detail later on when we talk about creating databases and planning for the data storage and the log storage. But no matter what, you need to plan for this, and you need to identify the storage options that are available to you and which options are going to work best in your environment. A couple of considerations you definitely need to take into account. First and foremost is if you have a SAN available to you, storage area network, who manages that SAN, and do you have any input or control over how those SAN objects are allocated? SAN administrators, as a general rule, care more about fault tolerance and redundancy than they care about performance. As a SQL administrator and a SQL designer, you're going to be very interested in the performance more so than the fault tolerance, because you're going to be able to enable the fault tolerance through your own creation mechanisms inside the SQL environment. So you need to look at that process. A lot of us will talk a lot of times about putting your database and your transaction logs on separate physical devices. If you're using LUNs from a SAN and you make the assumption that two different LUNs are on two different physical devices, when in reality the SAN administrator has carved up a single physical device into multiple LUNs, you're not getting the fault tolerance that you think you're getting by having them on separate disks. We also can use direct attached storage, which is dedicated, which is part of the system, usually in a housing or part of the physical system itself. The advantage of direct attached storage is it's usually relatively inexpensive in grand comparison to other types of storage. The problem is it's very limited in its size. You're limited by the physical connection options that are in the chassis that the hardware is attached to. We can implement RAID systems. We're going to look in detail a little bit later on at the different RAID technologies. There's a bunch of different ones that have been brought out of late. We're not going to focus on some of the ones that people brought out and then didn't actually implement. But we'll talk about RAID 0, RAID 1, RAID 5, RAID 10. RAID 0, very dangerous, striping without parity. There's no fault tolerance in that. But you get very good read and write performance from a RAID 0. RAID 1 is mirroring. RAID 5 is striping with parity. And RAID 10 is mirrored stripes. So, you know, we can get some pretty good performance by implementing these RAID technologies. We can also get fault tolerance with all of them except for RAID 0. The number of drives that are in your storage array can also affect the performance of the storage array. The more drives you have, the theory is that we can write across those drives simultaneously. You're going to hear a lot about JBOD in some text, not in the text that you have with your course, but in some other text, just a bunch of disks. And some of the advantage of JBOD is I can actually implement separate disks and volumes and use things like Windows storage pools to allocate these and then make sure that I'm writing to multiple disks simultaneously. And if they're running off of different controllers, then I really get some improved performance on that. So the number of drives, as a general rule, as the number of drives goes up, you're going to get better performance. But obviously there's a point at which you get a reduced rate of return. When you have too many drives, there's too much management, too much overhead. You don't get all the benefits of the extra drives. We also can do caching. As a general rule, read caching doesn't do you any good on any storage devices because SQL Server has its own caching mechanism for that we already talked about. We have a data cache. The data is going to be brought into the data cache. That's the read cache. Having that on storage technologies doesn't do you any good. You can implement write caching through the controllers. There's a huge catch here. If you're going to implement write caching controllers, you have to make sure that the write caching controller is able to write the data to the drive even in the event that the underlying system has a failure. Because if you don't, when SQL thinks that it's written the data to the disk and it transfers it through the SQL OS to the underlying storage infrastructure, as far as SQL Server is concerned, that data is on the disk. If it's in the cache of the write controller and it doesn't make it on the disk, you have a serious integrity problem and a corruption problem in your data. So while it is possible to use write cache and controllers, there's a lot of requirements you have to make sure of before you implement those types of controllers. So when we start to plan our I/O performance, our disk I/O performance, there's a couple of tools that we can use. One of them is SQL IO Sim, and this is used for reliability and integrity tests on disks. Now, the integrity test is really integrity for SQL Server, not necessarily for the integrity of the disk system itself. But it allows us to create tests to evaluate the connections and the access time and the access and response time from the storage devices. What it lets us do is try to simulate I/O patterns, but for SQL Server transactions only, and that's very important. So this doesn't give us the ability to look at other types of technologies. It's specifically just SQL Server. There is a little bit of randomness to it, so there's some dynamic functions there that are, as we call in the SQL world, non-deterministic, which means they won't be the exact same each time we run the test. So we can't use this for performance tuning because we really can't guarantee that that process is the same each time, but it does provide a little bit of a stress test on the disk subsystem and tell us what the performance of that disk subsystem will be and whether we can use that subsystem as a storage infrastructure for our SQL databases. In this demonstration, we're going to look at how to use SQL IO Sim to simulate load for input-output operations on a SQL server that we're going to identify workloads. In this demonstration, we're going to look at how to use the SQL IO Sim using the graphical interface that's provided with it. To launch the SQL IO Sim, we will go to the SQL Server installation directory, which is Program Files, Microsoft SQL Server, Microsoft SQL Server 13 MS SQL Server, that's our instance, MS SQL, and then we'll go to the bin.n folder. And in the bin.n folder, we will scroll down to the SQL IO Sim, which is going to be down in the S's. And there's the SQL IO Sim, and we'll go ahead and run this as an administrator. Now this is the graphical interface where we can control the processes that it's going to use for the SQL IO Sim. First thing we're going to do in this example is we're going to set the duration to 30 seconds, so that's going to be half a minute. In real life, obviously you're going to want to test this a little bit longer. In the test cycles, we're not going to have it recycle and run over and over and over again. We're simply going to run it once to do one instance. And in the error log, we're going to make sure that this goes to our D drive that we're using for all of our course files. And we'll go ahead and put it in the SQL IO Sim .log.xml file. And now we'll go ahead and click OK to save our settings. And over here, we will go ahead and start the IO Sim. So this is going to run for about 30 seconds. And it's going to generate some activity simulating input-output operations that are occurring on our SQL Server. So what we can do is we can wait about 30 seconds or so, and after we allow it to run for a short period of time, we'll go ahead and go to the stop, and we'll go ahead and stop the IO Sim, and then we'll look at the file that was examined. Now first, you can see the results. You can see right here it's doing a bunch of file activity on the SQL Server. So we have some multi-dimensional expressions, we have some log files for those, the LDX files. We have it creating files right here, again LDX and MDX files that it's creating. If you scroll further down, you can see right here it's doing some drive configurations. So you can see what it does. It goes through a series of configuration settings and simulates use of the input-output operations for us with a specific focus on the hard drives. So if you remember, we told it to store the results in our D drive under SQL IO Sim.xml. So here's our output file. We'll go ahead and open that. With the Office XML handler, and that's going to be a parser for XML. And you can see the results here are exactly the same as what we saw in the graphical interface. If we were to have run this tool using the configuration command line, then we wouldn't have the output in the graphical format, but we'd still have the XML file that we could view again later on. In this demonstration, we got to see how to use the graphical components of the SQL IO Sim to test workloads against a potential SQL server. So another tool that we can use to assess I/O for SQL loads and SQL usage is something called disk SPD. I think it stands for disk speed. But what it lets us do is generate a load on I/O subsystems. The advantage this thing has over IO Sim is that it allows us to actually do a predictable load, and it is suitable for performance tuning. The disadvantage to this tool is we actually have to download this tool. It's not included with the SQL distribution media, but we can configure it for generic IO subsystems and for generic activity, or we can configure it specifically for SQL activity. And obviously for us, we would want to configure it specifically for SQL IO to identify the IO that we're going to use for SQL Server against a disk subsystem. This tool supersedes or replaces an old tool that we used to try to do this with called SQL IO. And this allows us, again, to test subsystems, specifically disk subsystems, IO subsystems, for SQL activity before we actually install SQL. In this demonstration, we're going to look at how to use the disk SPD tool to simulate I/O and disk operations for a potential SQL server. In this demonstration, we're going to look at how to use the disk SPD program to simulate storage subsystem load to determine if it's appropriate for a SQL deployment. So in order to do this, we have to download the application first, which has already been done for us. So now we're going to open up PowerShell. We're going to run it as an administrator, and we're going to browse to the directory that they have downloaded the application to. So for us, that's going to be on the D drive. In our demo folders, mod 02, disk SPD version number, AMD 64 FRE, and then what we're going to do is we're going to run the disk SPD here, and we're going to type disk SPD.exe, and we're going to put in the switches that we want to use. The size of the file that it wants to create, which for us is going to be 2 gigabytes. We're going to do random read operations. We're going to allocate 4 threads. We're going to allocate 40% for write operations, which leaves 60% for read operations. We're going to implement 32 I/O operations per thread, and we're going to set the block size to 64K. Now, you can get the list of parameters by doing disk SPD /?, and it's important to note that all of the parameters here are case sensitive, so there's uppercase and lowercase parameters. We're then going to specify where it's going to store the results, so we're going to put that in test.dat, and then we are going to specify that at the end of the operation it will delete that test.dat file. So we'll hit enter, and that's going to run our operation for us. And again, what it's doing right now is it's doing some random input-output operations utilizing the subsystem. This tool is not designed specifically for SQL Server. It's designed for any storage subsystem. Now, for some reason, it couldn't find our test.dat file, so it couldn't delete the test.dat file, but that's okay. We got to see, this is what we wanted to see in the operation. So this is where it ran, this is the input-output operations, and this is telling us the ratio and the amount of information that we specified. So there's our block size, 64K. There's our 60/40 read versus write operations. There's the number of outstanding input operations, which was 32. Here's our number of threads per file, so that's 4. The size of the file is not listed here, but you can see that's where it's going to put the file. So then when we look at the process here, you can see how long it took, 10 seconds, the number of threads that it used, the number of processors that it used, and you can see the amount of load that it placed on the system during this operation. This would be useful because unlike the SQL IO Sim, this is a predictable tool that will provide the same amount of results every time. In a SQL term, we call that deterministic. So it's going to give us the same results each time, given the same conditions for the operations. In this demonstration, we got to see how to use disk SPD, the command line options, to identify and simulate workloads on a potential SQL server. So another option we have to having multiple servers installed, so we already talked about how we can have a single physical machine and have multiple SQL Server instances on that machine. Another approach is to create virtual servers that are virtual operating system machines running on a single physical host, and then have separate SQL Server deployments in each of those virtual machines. Microsoft introduced Hyper-V in Windows Server 2008, and that gives us the ability to create virtual machines and allow us to have multiple servers running. One of the drawbacks that we have with the virtualization strategy is they are dependent on the physical structure of the host machine, and you have to be very careful when you're planning your virtual deployments. SQL Server is one of those products that's very dependent on the I/O subsystems, and oftentimes people don't plan that carefully enough, and they end up with some bottlenecks at the I/O subsystems. We could also implement a new technology which was introduced in Windows Server 2012 R2 technically, but your book says 2016, which is called containers. And what we can do is it uses a technology developed in the Linux world called Docker, Docker D, the Docker daemon service, to allow us to create containerized applications that share some information from the operating environment but still run independently. With containers, we can actually run the operating environment, run the SQL environment, and reuse some objects that have been defined and deployed, so it's less of a footprint for the individual components. It also is a faster boot up time because it doesn't have its own operating system like it would in, say, a virtual machine. The one thing your book does not mention that you need to be aware of here is there's also a downside to that. If you have a problem and the problem is the operating environment, then in a container, all of the containers running on top of that operating environment would be damaged or corrupted by the problem. So you need to take that into account when you're trying to evaluate whether you want to go virtualized or containerized. We can run SQL Server in either environment. There's a link in the text that talks about how to get instructions on how to create a containerized version of SQL Server. You're going to do a lab later on at installing SQL Server in a Hyper-V VM running in Azure. So you're actually going to create an Azure VM and you're going to install SQL in that Azure VM. We're also going to do a demonstration later on when we talk about Azure. So there's a lot of different ways. Those are the cloud options that we have. Both containers and virtual machines are available to us through cloud services, through Azure, and we can create those environments in the Azure world to allow us to create virtualized deployments. Now, one thing your book does mention, the text does mention, is you want to be careful here. If you're going to create a SQL instance and you're going to try to use that instance to create more instances later on, in Windows, we would say we had to sysprep or generalize the virtual machine before we could deploy it to other VMs. Well, SQL has a similar process. So we can sysprep a SQL installation and then use that to deploy SQL across multiple virtualized instances. So one new option that we have with SQL Server 2017 is the ability to install SQL Server on Linux distributions. Linux distributions of Ubuntu, Red Hat Enterprise Linux are supported, as well as SUSE. So we have the ability now to install SQL Server on Linux platforms. The idea behind this is that a lot of organizations nowadays are looking at virtualization strategies, and with these virtualization strategies, starting in Azure now, we can actually deploy Linux virtual machines, and then we can install SQL Server on those Linux builds to help us identify and run our SQL processes in a different location. SQL 2017 is the first version that allows us to run this on Linux builds and Linux containers. Now, we talked previously about containers and the benefits of those, and they reiterate that in your text. So you want to read through that and understand the container concept. But the idea here is that we now have the ability to install SQL Server on a Linux build to allow us to leverage other applications that are running on those similar Linux builds. So SQL Server has a lot of system databases that we're going to look at as we go throughout this course. You have master, model, MSDB, resource, and we also have TempDB. Now, TempDB is unique from all the others in that it is a dynamic database that is completely rebuilt every single time the SQL Server service for an instance starts. So when SQL Server starts up, it does recovery on all the system databases, and then it clears the TempDB of everything. TempDB is used by pretty much anything that's going to access the SQL environment. All of the things like sorting and filtering and building of data, building of result sets, all of those functions are going to involve the TempDB database. Now, in older versions of SQL, somebody at Microsoft came up with a plan, 2000, I believe it was 2000, that you could store TempDB in RAM. And it sounded like a great plan. And if you think about it, you go, wow, yeah, memory is 1,000 times faster than disk. What a plan. The problem that they found was that it actually causes the entire operating environment to slow down. So it really didn't work out well. Instead, now they recommend you create multiple data files for the TempDB database and have those data files stored across multiple physical disks. That allows it to parallel read the data from the temporary environments and write data to those temporary environments while it's building data sets. So it's a shared resource, so you have to make sure that the TempDB has enough disk space to start with. We're going to talk about creating databases later on, but one of the things you're going to do is you're going to create a database and you're going to set the initial size, and that's how much disk space is going to be allocated when the database is created. Well, remember, the TempDB is recreated every single time the SQL Server starts, so it's going to reallocate that space every single time. It's actually just going to clear it. The files are already there. It then will increase the size. We're going to talk about auto growth a little bit later on, and we can specify the increment with which the database needs to increase in size. What this does is it allows us to configure how much more space to allocate each time it runs out of space. Now, for this, the larger the amount, the more efficient the process will be. However, that means that that space is not available to anything else in the operating environment. So you can't make it too big, but you certainly don't want to make it too small. So we can control that. So we have to identify the resources that are going to be accessing this data, and we have to identify the amount of space that's going to be used. And really the only way we're going to be able to tell this is by monitoring the environment, monitoring what goes on, looking at the dynamic management views and identifying how big the TempDB is and how much space is being allocated and how much is expanding, and then adjusting the number of files and the size of those files and the growth increment of those files. So with regard to TempDB, there's certain things you can configure during the installation of the SQL Server, where the TempDB files are going to be stored, the number of files you're going to allocate to TempDB, the initial size of those files, the auto growth increment. You could theoretically also specify the max size of those files as well. We can also change these at any time. And as I already mentioned in the previous discussion, we have to make sure that there's plenty of space available for TempDB. As we talked about earlier, if there's not enough room in the TempDB, when it goes to put something in, it's got to move something out in order to create the space that the TempDB needs, and that's going to be reflected in performance degradation. So a lot of different options for installing the SQL Server. The way many people do it, especially people that are new to the environment or that want to actually get a graphical representation of what's going on, is to use the installation wizard. The installation wizard has a bunch of sections. You have the ability to identify the planning, you have the ability to identify the features, you have the ability to identify the component configuration. There's an upgrade advisor option. It'll help you download and install the upgrade advisor if you're going to upgrade. So it's got some processes for it that can automatically walk you through the process. You can also install SQL Server from a command prompt. From a command prompt, you simply identify the location of the installation media, whether it's local or on share, and you run setup.exe, and then you specify the switches that are going to be the properties that are going to be associated with the install. We can combine a command prompt installation with a configuration file, and then all of the options that we want, like what features we want, what accounts we want to use, what settings we want to do, any customizations like to the TempDB adding files, those can all be configured in the configuration file, and those will be passed to the setup. If you do a setup command prompt installation and you specify switches in the command prompt, and those settings are also set in the configuration file but differently, the command prompt overrides the configuration file. In order to run the installation wizard, you have to be an admin. In order to do the installation of SQL, you have to be an admin on the system where the installation is going to take place. As I mentioned previously, if you have an installation of SQL Server that you've already created, you can actually grab a copy of that installation that you can then use to deploy it to other physical machines or virtual machines by sysprepping it and then deploying that image through technologies and products like Virtual Machine Manager. You can deploy them into the cloud, into Azure VMs. So there's ways to actually grab the SQL image as opposed to the operating system image, and that allows us to deploy SQL to multiple virtual machines. So if you choose to use the installation wizard, you're going to see a bunch of different screens that are going to show up, and the number of these screens that you get depends on the number of features that you choose. What they don't show you in this slide here is the first thing you're going to see is a product key screen. Now if you're doing an eval copy, you can say install the evaluation, don't put in a product key. If you do the evaluation, it's got a limited time window. If you're using a developer edition, the product key will automatically be filled in for you. Then from there, you have the license agreement screen. You must agree to the license agreement before you can move further. That'll take you to the product update screen. And the product update screen, it actually is going to go out and check for updates from the internet. If you don't have an internet connection, you can check the box to tell it not to check for updates currently. That'll move you to the setup files, and it's going to copy the setup files from whatever the whatever the installation source location is, whether that's a network share or whether that's optical media. It's going to copy the files in. Then it's going to go through the install rules and make sure there's no problems with the system that might prevent it from installing the SQL Server, like you're not logged in as the admin. Then it goes to the setup role. And in the setup role, you get to specify whether you want to install specific features or whether you want to install all features with default components. If you choose specific features, you will get the feature selection screen, which then allows you to pick and choose which features that you want. And we talked about these before: database engine, analysis services, reporting services, integration services, data quality services, master data services. All of those things will become choices here. Some of them, depending on where you are and whether you're doing upgrades, may not be available. Some of them also have external dependencies, like we talked about. Power View and Power Pivot have dependencies on SharePoint installations. After you choose the features, the next screens will change based on the feature selection. So you'll then have the option of configuring the instances for each of the features that you've defined. This is where we define the instance name, whether we want to use the default instance, a named instance, what settings we want for the instance. And then we get to the server configuration, which in my opinion should be service configuration. That's where you define the accounts, the passwords for each of the services, the startup configuration for each of the services. Then you get to each of the components. Again, this screen is going to be dependent on the features that you configured previously, and that allows you to configure each of the individual feature components. And then lastly, you'll get the ready to install screen. Now what's really important is, once you get to the ready to install screen, SQL has now created a configuration INI file, which you can then use in the command prompt installation to do the installation. And it's going to be in the default installation folder, Bootstrap logs folder. You're going to have a configuration INI file based on the date and time stamp of the time that you ran the installation wizard. So we can use the installation wizard as a method to create an INI file that we can then use to script and install across multiple systems. So after you've done your installation, you want to verify that the SQL installation succeeded properly. Two of the ways you do that, one's not listed here that I'll mention. One, check to make sure the SQL Server services are running. Again, depending on what you specified or configured in the server configuration, if you did the wizard, in the server configuration of the wizard, look at those services and make sure they're running if you set them for automatic startup. You can use the SQL Server Service Configuration Manager to identify the services and identify their startup value and change their startup configuration settings as well. Another way that you can verify is to open a DOS prompt on the physical machine that's running SQL, and open a connection to the SQL Server and run select @ version and hit enter and then say go and hit enter, and it'll come back with the version of the SQL Server. What that means is you were able to connect to the server and run a query against the server. And it's just a simple query that we can run from a command prompt. You can also open the SQL Server Management Studio and connect to the SQL Server instance to make sure that you can connect to it to manage it. The catch with that is you've got to have the SQL Management Studio downloaded and installed somewhere. The Management Studio is no longer on the distribution media. You actually have to download the edition from the internet. So that's a little bit of overhead that you may not have already done yet. If for some reason something goes wrong during the installation, we can look at the log folder for the installation in the program files, Microsoft SQL Server. Remember the version number I mentioned earlier? This is why we need to know the version number. So 13 is SQL 2016. We look in that 13.0 folder, and we have a setup Bootstrap, and we have a log folder. Remember, the log folder is going to contain an entry for the date and time stamp, and we also are going to have a configuration INI file in there that we could use to do installations. We'll also have a setup log file that will be there to tell us if something went wrong during the installation. So SQL Server servicing is the updating process that we do for SQL environments. Unlike many other products, SQL Server still maintains the old servicing methodology that we've had for a very long time. If we have a potential, usually a security vulnerability, there will be what they refer to as a hotfix or a quick fix. So QF, you'll see, QFE. We then combine those together over periods of time to be one significant update referred to as a cumulative update. You'll oftentimes see version numbers listed as CU4, CU3, CU5. That's cumulative update level. Oftentimes features or upgrades require a deployment to be in a certain cumulative update level before you're allowed to upgrade that to another version. And we have service packs, so SP1, SP2, SP3. Those allow us to identify a certain stage of cumulative updates. So hotfixes combined together make up a CU, CUs combined together make up a service pack. new to SQL, new to Microsoft, about 6 or 7 years ago, roughly. So right around the 2008 environment, they gave us the ability to slipstream updates. And what that lets us do is when a service pack comes down or even a cumulative update comes down, we can actually take the update, run the installation of the update with a /slip switch. And what that will let us do is reference the source location for the files. This can't be optical media, it's got to be a writable location. But we can copy the installation folder from the optical media and then slipstream the update in there. The next time we install from that source, it'll have the update in it. So that can be with CUs or with service packs. You can also configure automatic updating. Many people do this. You use products like WSUS, Windows Software Update Services, and that allows us to bring the updates down, allows us to identify which updates Microsoft has available to be installed, and then we can choose to approve those updates across our servers. In order to do that, the operating system that the SQL Server is running on has to be configured for updates from a WSUS server, or we can get them from the Microsoft environment. The advantage to doing it through WSUS is we can control the deployment. We could also use products like System Center Configuration Manager to do those updates as well. So as mentioned previously, we can configure SQL Server to run automatically the installation without any user input whatsoever. And there's two ways to accomplish this. Both of them are going to involve the command line option, but in the command line, and that's what this is an example of the command line environment. So when we look at this, this is the actual command line, setup.exe. The /Q switch means quiet. That means no feedback on the screen about the installation process. There's another switch that we can add with that. We can add QP, and that P is going to be progress, right? And so what it's going to do is it's going to show the progress that's going on with the environment, but not require any user input. When we do this, instead of doing it with this, we could also put in an unattended answer file, and we could specify the configuration INI file that will provide the information to the installation. These are two different examples of doing the setup. The only real difference between the two is this one has complete image, this one is an upgrade. So the action is different. This is going to be a full install with this complete image action. This is going to upgrade an existing instance. This is going to create a named instance called my new inst. This is going to upgrade the default instance. Remember, the default instance is always called is by default called MS SQL Server. And you'll see that it's going to run upgrade, and you're going to specify the account that it's going to use that has sysadmin role privileges on the server. Here, we're going to specify the account that's going to be used to do the installation. This is going to become the service account that SQL Server is going to use to run the services. So we talked about service accounts earlier. Notice they're using a domain username, right? Then they're specifying the password. Now, most of you will look at this and go, the problem is we're putting the password in a text file. So this would not work well in a text file, right? Because anybody that knows this password probably knows an account that has pretty high level privileges on SQL. If this is a managed service account, then remember, we can't log in with a managed service account. That's one big advantage to a managed service account. This is going to specify what account is going to automatically be added to the SA role. There has to be at least one account in the sysadmin role. In older versions of SQL Server up through 2005, members of the domain admins group were automatically added to the SA role, and they found that that was a problem. So starting in 2008, you actually have to tell it what account needs to go into the SA role. And then notice here, accept the license terms. Remember, you always have to accept the license terms. So this one's just a little bit different. We're specifying the service account that we're going to use, and we're accepting the license terms, but we have much fewer information that's being provided to the installation process. In this demonstration, we're going to look at an unattended answer file for installing a SQL Server instance. In this demonstration, we're going to examine the contents of the configuration file INI, which will let us do an unattended installation of a SQL Server. So first thing we're going to do is open up a sample configuration INI file, and there's a configuration file.ini. And if you look at the contents of this, the first thing we want to look at is, notice this would be doing an install instead of an upgrade or a removal or an uninstall. We can specify quiet. Quiet won't display anything to the user. Quiet simple will show a progress bar, but nothing else. Under the features, we can control which components of the SQL Server environment will be installed. So we can control the components here. We're going to install the SQL Server service, the engine, the replication service, advanced analytics, the full text indexing service, the data quality service, polybase service. And then we have some integration pieces with analysis services, reporting services. And if you scroll out a little bit further, you'll see some of the other components here, like Books Online, the SQL Server Management Studio. So we can control all the different components that are going to be installed as part of the installation process. If we scroll a little bit further down, we can determine where the installation is going to occur. So we can specify the destination for the shared components as well as the SQL Server installation components. We can also specify the name for the instance that will be supplied. Again, remember, this has to be unique on the individual SQL servers. If I have multiple instances running on the same server, you'll notice there's the instance name, and we also have the instance ID for the features that we're going to be running. We can then specify the accounts that are going to be used, and if we come down a little bit further, you'll be able to see the SQL agent service accounts that are going to be used. So here's my agent service account. This is going to be the account that's going to be used for the SQL Server. So there's the instance directory where the SQL Server instance is going to be installed. This is going to be the account that's going to be used. And we can also specify the startup of the service so that it will automatically start up after the installation is complete. If we scroll a little bit further down, we can see some other parameters, like the accounts are going to automatically be added to the SQL Server sysadmin role. That allows them to automatically manage the server. Again, depending on what features we implement, we can control things like the file stream properties. If you look up here a little bit more, you can control things similar to the command functions within the environment. We can enable the RANU settings for SQL Express. We also have right here where we can set the collation that's going to be used, and we specify the SQL Server service account that's going to be used to manage the SQL Server instance. And again, here's the sysadmin accounts that we talked about before. Notice here we also can specify the security mode. This is going to be the preferred authentication method. Now keep in mind, if we go with SQL, we have to specify the SA account and the SA password that's going to be used for the instance that's being installed. Notice here that the TCP is going to be enabled, so 1 is enabled. For name pipes, I'm sorry, 0 is for name pipe, so that's disabled. 1 is enabled for TCP/IP, so the TCP/IP protocol will be the only protocol that we can use to connect to this SQL instance once the installation is complete. In this demonstration, you got to see how to identify the configuration INI file and how we can use that INI file to do an unattended installation of a SQL Server instance. In this lab, you're going to look at installing a SQL Server. You're going to start by looking at installing the prerequisites required to install a SQL Server. You're then going to perform the installation of the SQL Server. You're then going to perform some post-installation tasks that need to be done on the SQL Server. And lastly, you're going to look at the process for automating SQL Server installations. This lab should take about 90 minutes.